All right, cool. All right, so Todd did a great job of introducing me, and thank you, Todd, for allowing me to present my work. So this is about a 23-minute, 24-minute presentation, so I'm gonna kind of go through my research here, or my own fine art research. So I'm an associate professor in the School of Visual Arts. And like Todd said, I do a lot of transdisciplinary research. A lot of it's icat based is where a lot of this stuff has started, and it has migrated outside of icat also. But today I really wanted to talk about more of my fine art work over the past decade or 8 years here at Virginia Tech. And so I kind of hand selected 4 of them that I'm proud of. And a lot of these are using technologies and also physical making. So we'll go ahead and get started. And so I'm a 2-time recipient of the Joan Mitchell Joan Mitchell grant. And I also was part of their pilot program, the residency program in New Orleans. And so when I went to New Orleans, I had a lot of these parts and pieces that you see here in the video in my duffel bag. And then I brought on the IKEA sewing machine as a carry-on. So you know it's going to be a wild time in New Orleans when you bring your own sewing machine. And so when I was there doing a lot of sewing and fabricating, so that's always part of my process, is fabricating physical forms to either interact or be with, kind of a sculptural and also kind of my painting background. And so during the evening, I would do modeling and then rendering in the evening, and then post-production midday. And all this was in the French Quarters, the studio that we have to get to work with. So part of my process is also sound design, and I collaborate with Tom Judson, and we've been collaborating for almost, hate to say it, 2 decades. We've been working together creating interactive artwork. And so he's developed a max patch here, and this is kind of the early development of this kind of a procedural call for sounds, looping sounds, and procedural sound, and also video. And so the end result was kind of this interactive piece that you would walk up and see, and each time that you saw it would act differently and behave differently. And so this looks really awesome, but this is in the French Quarters in the middle of a bathroom, because it was the only place that we could get dark enough for the projection mapping. But it went on to go to several other exhibitions, and one in Calgary and then somewhere else. So a lot of my work is some seed funding, competitive seed funding grants, maybe sometimes in the $3,000, maybe up to $10,000 grants, and some larger scale grants also. And in the background, you saw one of my students, Fat, we keep joking about. But as part of my research and my teaching is I fold in my research within my teaching methodologies. So always hiring students to be part of my process, either in fabrication or rendering or modeling. And so it's a key process. So the project that you see here is the nanopods, and these are pods that we projected within the icat cube. And so there's this kind of physicality of these things projected and interacting with you. So the third project is a collaboration with Eric Line, and he was created a score for the icat cube using 3-dimensional sound. And really briefly, you saw there was a cyclorama, and it was the first time the cyclorama was introduced to the icat space. So it was a whole new tool. Had no idea how to do 360 or stereoscopic rendering, but Zach Dewar at the time was working at icat and helped pioneer some of those pipelines. And so I think this was pretty quick. We did this in about 40 or 50 days, the rendering and then animation. And so there were about 3 different cycles of different types of animation that interacted with the 3-dimensional sound of the room. So it was quite fun and hectic to try to pull off learning new methodologies and techniques. So one of my favorite pieces is the Sound Arcade, and this was part of the Accelerate Festival at the Smithsonian. I think this was 2018. And this really got into the public. And so usually my work, maybe kind of like this presentation, like 10 people show up or maybe 12 and I'm happy. But this one, there was like 3,500 people physically interacted with it. And I don't know how many people walked by passively to check it out. So this was a collaboration with Georgia Tech. Matthew Swartz helped develop those sticks that you see there, those were interactive wands. So up to like maybe 40 or 100 people could interact at once, and each one of them, they could dial and do different colors and make a different sound. So when you clicked it, it would send out a radio frequency and make a certain sound. And also at night, when you clicked on it, it also make a splash animation on this projection mapping that you see here. So you can start to see different colors here. So we had over 256 different colors and 256 sounds that you could choose from. So you could imagine 40 to 60 people all with these wands hitting it, and these multiple sounds layering on top of each other. So it was really, really awesome experience. Again, folding this into my teaching methodology. So I think 6 to 8 of our students were part of this. And Todd was the big role of this. He actually traveled for an hour to get 20 yards of white spandex. So he was a big hero for this project. And I don't think he's been to a fabric store since. So again, it was a really amazing experience. We did it pretty quickly. We were able to fabricate everything and do the animations in probably about 30 or 4 days. And also it was funded through icat, and also a lot of people at icat helped facilitate it, and also the programming of it also. So really cool to get a piece out into the public, a whole new engagement and a whole other level of VR, or not VR, but interaction with people in the audience. So as Todd said, last year was my VT research leave. It's the first time in my academic career that I had a semester or a whole entire year off. And so the summer before, I had gone to New Zealand as a workshop that I'm part of, and a Japanese workshop that was hosted in Wellington. And Mark Burrell, that I've known for a decade, invited me to come. And so I got to live with him and his family in Wellington for the semester. And also he's the dean of the school. So I got to see the inner workings of the university also, and be part of some meetings and also presentations. And also a little bit of it was at University of Auckland. This is on the northern tip of the North Island. And so I got to see their methodologies and their research centers, which were pretty pioneering stuff that they do within their architecture program. Also, I didn't have strong ties with Wedded Digital, but I did have a couple of mentors that I got to meet several times to talk about my project, and they were had some significant weight on what I did with my project. Also, a shout out to icat. The second part of my research leave was here at the icat facilities, and also icat had a buyout for my second semester for my research leave. So this was really critical for me to have enough runway to work on my VR project. So this is the first time I really got to just focus on one project. Usually the 4 projects that you saw prior were really quick, like 30 to 40 days. But this time I get to work a whole entire year on it and really get to strategize and make it as big as I want. So this is a project that I'm going to show you is called a virtual sensory convergence. And really what I wanted to do is create a virtual reality experience. And typically the VR things I have created or been part of is usually just visual and maybe auditory. And sometimes we've had a couple of touch things where we used a VIVE tracker. But I really want to kind of culminate all these into a really cool experience with all these 5 senses. And again, I really wanted to jump into Unreal Game Engine. As you know, as you're a teacher or professor, there's a level of atrophy, and you start to learn, not learn anymore, and things start to be beyond you. So this is my time to learn Unreal. So just a little bit about what you're about to see. All these forms and things that you see start from meditation. So that's part of my daily practice, is meditating and doing those really quick drawings that you saw right there. Those are typically done in dark. And so they're really quick sketches just to remind me what the meditation was. And typically I see these kind of weird abstract forms, and then I start to build them out. And so what you see on the screen is just me taking those really quick notions of those sketches and start building out these models. And what you saw there was in Maya, and also the UV mapping, laying that out, which takes a lot of time. So that was basically a lot of my work in Wellington was building that. And so part of that process, I start to think about textures. And so I start to gather like a mood board of all these different textures and colors. So I'm really drawn to fashion and obviously kind of technologies used in sneaker design for textures. And so I look at those and start to combine them to like these characters that I created and start to work on textures. And so this was in Substance Designer that you saw. Those were the textures being applied to the model. And then part of the process also was rigging. And so you can see the rigging in Maya so that these forms can kind of undulate and move in this space. So I'm just kind of giving you little snippets of what it looks like, the breakdown of the modeling process, and also Substance Designer and Substance Painter here. You can start to see how that light refracts off that surface. And what really drew me into Unreal Game Engine is the global illumination and how you can take Substance Painter and export the 5 or 6 or 7, sometimes texture maps onto these forms and create these really amazing surfaces. So here we have a form that has subscatter surface on there. That's the same way that light hits and penetrates your skin. So you have the epidermis and the dermis layer, and then once it bounces out, it's combining all those surfaces to create that illusion of that color. Again, I was really excited about taking those really low polygon forms and then adding really high dimensional surfaces on that. And typically this would be the million polygon count, but this is very, very lightweight and using those maps on top of a very low weight form. And so as part of my, some of the mentoring with Weta workshop or Weta digital people were saying, you know, don't worry about skeletons. You can add as many skeletons as you want. It won't slow down the game engine. But they said my fondness for transparency was going to be an issue because like the form that you see here has up to 5 or 6 layers of transparency. So that's typically a hard thing for a game engine to handle in real time. So going beyond 60 frames per second or 30 frames per second, this can be an issue. So again, I'm showing you just kind of snippets. You're going to get to see how this all interacts in just a second, but I'm just breaking down what these forms look like and how they are built up and textured. So I'm showing you a little bit behind the scenes of blueprints in Unreal. And so these are the character colliders. And so this is a node-based system, which I gravitate to because I'm not a coder, but I can understand conduits and brackets and so forth. So for me to understand this is a little bit easier. So when I came back for the spring semester, I had Daniel Munzel and David Franusich to help out with this. And we were working with the VIVE tracker. So we're basically working with 8 VIVE trackers at the same time. And you see over to the left, we're using a VIVE tracker and the pogo pen. So we can send the signal through the pogo pen of a VIVE tracker and interact in real time to the Unreal Game Engine. And what you see here are the nodes what is receiving it. So it can do a hue shift for a character. It can do trigger off particle events or shaders or even emissive lighting that is on that form. And so you can see how complex this is. It's probably a little bit more complex than it looks, but each one of those buttons that you see would trigger off an event for these characters. And there's 8 characters that are being performed by puppeteers in this space. Again, this will make a little bit more sense when I show the overall thing. That last thing is sending out OSC signals when we collide, so we can make really quick changes on the sound design. So we're also working with sound design within this space of this project. So right here is this overall VR controllers and a little bit of adjustment that we did on that. So anyways, I just wanted to show you just behind the scenes the programming that took place on here. And again, using blueprints a little bit different than coding and other programs. So the next step of it is not just the visual, but the physicality of it. So I really wanted to take those forms that I modeled and then replicate them to 1-to-1 ratio. So If you're wearing a head-mounted display, when you reach out, you're touching this form in real time, and it's also floating and moving around, and it's responding in sound, color, and touch, and also smell. So one of the first things is to fabricate them perfectly. So this is in the basement of Victoria University, and a really cool system they have set up right across the hall, which is 10 feet away. You can buy your gold phone, and then you actually buy your tech time. So you're actually paying this person that I'm over the shoulder and pay for his time to use his expertise to mill it out exactly what you want. And they're using a Rhino pipeline, Rhino to the CNC. And a lot of their fabrication shop is loosely related to what's happening within the film industry. So what they're doing at a workshop, those techniques are carried over, like the 7-axis milling machine or robots. And also they had one of the largest 3D printers. And also they were doing voxel printing, which I hadn't heard of before I got down there. So you can see some really horrible epoxying job I did on my form here. And so you can, just showing you this, I have no idea, but anyways, showing this kind of learning curves. And so this went through a second and a third and a fourth round of working on the surfacing of that. So when I was down there, I really wanted to work with the idea of puppeteering these forms. So these objects are going to kind of reach out to you, and I want the participant wearing the head-mounted display to reach out and grab them. So I needed a quick way and a cheap way to create puppeteer armatures or forms for the puppeteers to hold. And also part of that was having the VIVE tracker to track it in real time, so everything is relative. So you can see the VIVE tracker is attached on the top, and for like less than $5, I have this gimbal to hold everything and to kind of act out these parts. And so I did a little bit of post sound on this, just kind of play around with what it would look like when I touched it on the bottom. Okay, and over to the left is this kind of representation of what we have modeled and textured so far. So it's getting exciting about this, and we haven't even got it into the game engine yet. So that was just down the road, and it was really nerve-wracking because I had no idea how I was going to pull this off. And so this was right outside our lab, and so PhD students and grad students were watching me, really thinking I lost my shit. So it's kind of exciting to make those iterations, and it's changed a lot since then. And so one of the ideas was smell and taste, how to introduce that. And so the product that you see there on the bottom right there is called a volcano, and it's able to take like oregano and infuse it and then create a smell. And so these are like smell bags. And so the idea, we're gonna have a scent for each of these 8 characters. And over on the left, you see these characters or these people holding these cubes, which would be a box fan. And at the correct moment when the person touches it, there would be the smell or scent fused out to enhance that experience even further. So it's just not sound and visuals, it's also scent. And so I've been working with Tom Judson also again, and we're working with the icat cube, and we're going to spatialize the sound. So when you're wearing a head-mounted display, you also have very many layers of sound. So you have the overall sound of this meditative sound. And then also we're gonna have 6 singers around the person with the head-mounted display doing vocals. And then also we're gonna have a Wii controller for to do independent sounds for each of these characters. So as that character is moving through the space and as you're touching it, it's responding in real time with different sound events. So I was lucky enough when I got back, Uwe from University of Auckland and also Mark Arell from Victoria University invited me to be part of a satellite representation of Ars Electronica. I was super excited. So wink, wink, I'm a New Zealand artist, but I got invited to participate. And so I'm just gonna show you what we had to do because of COVID. We had to limit how many people could be in the room, and it was my family. So my daughter and my wife, we are a pod, so we could get very close to each other without risking infecting each other with COVID. And so we didn't have a cast of 22 people to do the puppeteering for each of the forms and the sound and so forth. So we kind of create this documentary that you're about to see, and which was presented at Ars Electronica. So I'm about to go to the next slide. I'm not going to talk through it, but I'm going to let you watch it. It's about 3 minutes long, and then we'll wrap it up. So cool. So that was the end of the project so far. We're still continuing working on it. We're hoping to maybe showcase it a little bit further in December, building it out for a larger scale on the icat cube using the cyclorama and just a little bit bigger cast in a safe way. But again, a lot of cool things working with that project. So this is part of a 5-year plan. And so next year or this year, I'm working on a whole new interface, kind of using what I've learned on my first year, but building up on that. So thank you guys for listening.